Hey everybody, I'm meteorologist Ryan Hanrahan. I want to update you on the possible nor'easter for this weekend. Looks like it could be a pretty significant event. Some of our computer models are showing quite a bit of wind. There's the potential for storm surge flooding as well, coastal flooding. So we want to sort of walk you through this and show you what we're looking at. I'm going to take you behind the scenes into some of our computer model guidance and talk about some of the potential impacts up and down the East Coast from the mid-Atlantic up into portions of New England. Now, just make sure you're subscribing to this channel. Make sure you like this video, and if you have any questions, throw them in the comments. We'd love to interact with you, and if you subscribe, you'll be able to get notifications as soon as we post more of these videos, because we want to keep doing this as the weather gets a little more interesting. All right, let's take a look at what's going on. We're going to start things off with a brand new computer model that came out midday. This is the GFS computer model. What we've got plotted here is pressure, sea level pressure, and also precipitation, what we call QPF, which is quantitative precipitation forecast. And so what I want to do here is advance the clock up into this weekend. And so this is Saturday afternoon, and you can see the beginnings of this nor'easter. It's actually sort of a remnant of the cold front that moved through that brought in the cooler weather. It sort of stalls off the coast of Florida. And this is sort of the genesis of the nor'easter that's going to move up the coast. So here it is late Saturday off the Outer Banks, and then it continues to the north. But what we're going to see while the storm moves north is that there's still a big high pressure system to the north. See this H over Maine? That shows an area of high pressure that's sort of anchored in place. And we've got the low coming up from the south. And so it's the combination of the low coming up from the south and the high hanging on that's going to produce all the wind, because you get wind from a difference in pressure. So the steeper the pressure gradient, the difference between high pressure and low pressure in a shorter distance, that's how you get stronger winds. And watch what happens here as the storm comes to the north. That high does not move at all. It stays in place. It's locked in. The storm comes up through the mid-Atlantic, and so you get a really good difference in pressure across New England, and that's why we've got the potential for some very strong winds Sunday into Monday. And then the storm just sort of weakens and falls apart as it moves off of New England. So this is one of our computer model scenarios. Notice there's a lot of rain, then the rain sort of falls apart as the storm moves to the north. So I don't think this is a huge rainmaker for southern New England, but as it comes north, I think wind is going to be the bigger issue here. So here's what's happening upstairs as we take a look up closer to the jet stream. This is about 20,000 feet above our heads. And at least initially, you can see this system sort of lurking off the coast of the southeastern U.S. So there's this upper level low that's sort of stalled here, but at the same time, there is a really, really small but potent short wave, or this area of energy in the jet stream that's diving south, and that is effectively going to capture this whole system, bring it north, and allow them to sort of fuse into one. That's what gets the storm to move up the coast, but that's also why the storm is going to strengthen as we have that interaction, or the phase between the southern stream and the northern stream of the jet stream. That's why we've got this nor'easter that's going to form, and if it closes off here, it may stick around for a little bit, and I'll show you some of our computer models that are showing that. So let's talk about the wind, because again, we're looking at wind as the main threat here, and we're going to take a look. This is about 5,000 feet up. Looking at the wind, and this is what I use a lot of times to get an idea of how strong the winds could be down near the ground. So we look aloft, away from the influence of friction, to see what's happening. And notice here by Sunday afternoon, see this white shading? Those are winds that are approximately 75 knots, about 85 miles an hour above our heads, so about 5,000 feet up again. And that strong low-level jet moves right into southern New England Sunday into Monday, and it sort of sticks around for a little bit before it weakens. So that's a concerning look here, and I can show you a little bit lower to the ground. This would be about 2,500 feet above our heads, and you can see the storm comes to the north, and then you get this very, very powerful low-level jet. These winds here, 50, 60, 70 knots coming up towards southern New England and sticking around into the day on Monday coming out of the east. So that gives us an idea of how strong the winds will be just above our heads, how strong the winds will be aloft. The question is how much of that is going to mix down to the surface, and that is the what we struggle with to forecast a lot of times. We normally have a pretty good idea what's happening aloft. Coming down to the ground is a bigger question, but just this alone, this time of year, is a bit concerning. So that's one scenario. We'll go back to that in just a second. I want to show you some of our other computer models. This here is the European model. You can see the storm comes to the north. Bit of a different evolution. The storm is a little farther out to sea, but still same deal here. As we go over the wind speed, check this out. By Monday morning, you're still looking at these winds here that are 50 to 70 knots up high. This is about 2,500 feet up. So these are very, very strong winds just above our heads. And so again, the question is, how much of that wind is going to make it down to the ground and cause issues? Here's one more. I'll show you the Canadian model. Same deal. Storm is offshore, and then it sort of gets tucked back to the coast, and the Canadian just sort of keeps the storm swirling around for the better part of the week. So that doesn't happen. We don't need this storm to be here for a week, and it actually brings some heavy rain later in the week. This is probably not going to happen. This is sort of an outlier, but just something to keep in mind. So where's the storm going to go exactly? So here are a look at the ensembles. So we've got 50 different computer models, 50 different possible scenarios. This is the European computer model showing the storm coming to the north. And then there's a difference in location here, but the idea is pretty much the same, that the storm is going to be off to the south of us, and that puts the strongest winds on the northern side of the storm. The GFS, same deal, the storm sort of lurking off to the south, but close enough to cause some issues for sure. If the storm is over us, the wind would die down, but it's when that storm is to the south, that's going to be the issue. So as I talked about, when you got those strong winds up aloft, up above our heads, the question is, again, how much of that wind moves down to the ground? And to figure that out, what we do is we try to look at these soundings to figure out how unstable the atmosphere is. If the atmosphere is stable, those winds are forced to stay up there. They're not able to mix down to the ground. That layer of stability traps those winds effectively. But if the atmosphere is more unstable, then you can get those winds to come down to the ground through turbulent mixing. And what I want to show you here is, let's go to Sunday, or the Monday morning. This is a sounding for New Haven. And you can see, if you look closely right here, see the red, how it sort of goes from left to right? What that is showing you is that's actually showing this little area where the atmosphere is a little more unstable, where the temperatures are dropping with height. So there's no real stable layer here. So we potentially are able to mix down these stronger winds. And it's going to help that the water temperature on Long Island Sound is still in the mid-60s. Water temperature in New Haven Harbor is like 68 degrees. So that tells us that unlike a lot of storms in the winter, when you've got the coldest air right down the ground and you've got a bit of an inversion or a stable layer aloft, it's a little different this time of year. It's easier to bring some of those stronger winds down to the ground. And that's why I think we've got the potential for wind gusts, if these computer model solutions hold, could be up to maybe even exceed 60 miles per hour, especially along the coast. And that would be enough to take down trees and power lines, especially because this time of year, there's a lot of leaves still on the trees. In the winter, when the trees are bare, it's harder to take down trees because they're a little more resilient when they don't have any leaves. But this time of year, when we've got a lot of leaves on the trees, they're more susceptible to wind damage. And so that's one of the concerns we have with this storm. You get winds to 60, well, then you start taking down trees and power lines. The other issue is going to be coastal flooding, and we're a little lucky in this regard. What I've plotted here is the tides, the astronomical tide, so the tide because of the moon, effectively through the month of October. And right now the tides are extremely high because the moon is at perigee. The moon is very close, or not very close, but closer than it typically is to Earth. So you get a little extra tug, a little extra gravitational tug. So the tides are higher than normal. But by the time we get to Sunday and Monday, the tides drop some. So notice here, the tides are quite high. They've been quite high, some of the highest tides of the year the last couple of days. But by the time we get to Sunday and Monday, the tides begin to come down a little bit. So at least in that respect, the Sunday afternoon high tide's pretty high, but the Monday morning one is not that bad. So that's going to help us in terms of coastal flooding, because we're going to pile a bunch of water onto the beaches, New Jersey, Long Island Sound, Long Island, up to the Cape Cod, and eastern Massachusetts. So we're a little lucky in that respect, but again, we still have the potential here for coastal flooding. This is one of our computer models for coastal flooding, and showing that we've got getting close to moderate flooding in New Haven, same deal in Bridgeport, and also looked down into the mid-Atlantic, same situation there. This is Sunday, Monday, and later Monday. Let's go back to that in just a second. And then this is another, based off the GFS, and it's got tides approaching about 10 feet in New Haven. Major flooding in New Haven is 10.6 feet. So we're getting very close to that. So this is the potential to be a pretty significant coastal flood event as the storm comes to the north. So again, we're keeping a close eye on this. We're watching our computer models. We're watching that band of really strong wind come to the north. And again, the potential is there for damaging wind, enough to take down trees and power lines. Still, we've got about 3 days to watch it, but at least I want to give you the early heads up that this storm could be pretty significant for a couple reasons, mainly because the time of year, it's a little early for one of these strong nor'easters, and the trees will be a little more susceptible to tree damage than they would be if the storm was hitting about a month from now. So we're going to keep you posted on everything here. I'll keep you abreast of any changes in the computer models, but Sunday into Monday, still have to work out the timing of the worst of it. I'm going to